Okay, here we have a video on solving linear simultaneous equations. I'm going to be using the method of elimination rather than the method of substitution, and we'll look at substitution when we solve quadratic simultaneous equations a bit later on in the course. So linear simultaneous equations in two variables, so x and y, are our variables, will look like this, where A, B, C, D, P and Q are all given. So these are all numbers that are given in the question. The idea behind elimination is that we somehow make the coefficients of one of the variables the same across the two equations. So as an example, let's take this top equation and multiply it by C. So we get ACX plus BCY equals CP. And let's take the bottom equation and multiply it by A. And we'll end up with, again, ACX plus ADY equals AQ. And now what we can do is we can subtract these two equations because the coefficient of x is the same across the two. So we end up with BC minus AD times y, and that's going to equal CP minus AQ. And providing that BC minus AD isn't 0, then we can say that y is equal to this number, which I know the algebra looks a bit horrible, but that's because this is just a very general case. Okay, when we do a numerical example in a minute, it'll be nice and easy. And then you can take that definition of y, plug it back into one of these, and that allows you to find your x. Okay. Again, in terms of A, B, C, D, P, and Q. So that's a general idea of solving simultaneous equations by elimination. So let's have a look at this example. We've got 2x minus y equals 11, and x plus 2y equals minus 2. So first of all, what I'm going to do is I'm just going to look across the two variables and decide which is the best coefficient to make 0. And in this case, I've got a 1 here and a 2 here, or I've got a 2 and a minus 1 here. So I only actually need to multiply one of the equations by something. I don't have to multiply them both, as I did in the algebraic example. So I'm going to take this bottom one and I'm going to multiply it by 2. So that's going to become 2x plus 4y equals minus 4. Okay, that's taking the bottom equation here and multiplying it by 2. And that is so that the coefficient of x across the two equations is the same. So I'm just going to write this top equation down again. That's the top equation. And now if I subtract the 2, the 2x minus 2x, well, they disappear. 4y minus minus y is 5y. Just be careful when you're subtracting negatives. And then minus 4 minus 11 is minus 15. Divide both sides by 5. I end up with y is minus 3. And now if I take that definition of y and plug it back into either one of these, I can obtain x. So x is 11 plus y divided by 2. Okay, that's making x the subject of this one. But I know that y is minus 3, so it's going to be 8 divided by 2, which is 4. At which point it is always worth checking that the other equation is satisfied, just to make sure you've not made a mistake. X is 4, y is minus 3, so I get 4 minus 6 is minus 2. Perfect, that's what I want. So the solution then is x is equal to 4 and y is equal to minus 3. There we go. Okay, a more complicated example. 3x plus 2y equals 8, and 5x minus 3y equals minus 31. So this time I can't just times one equation by something, not without having decimals kicking around. So I'm going to take the top equation and I'm going to multiply it by 3, and I'm going to take the bottom equation and I'm going to multiply it by 2. That's so the coefficient of y is 6 and minus 6. So top equation times by 3 is 9x plus 6y is equal to 24. Okay, that's the top equation multiplied by 3. And I'm going to take the bottom equation and multiply it by 2. So that's going to give me 10x minus 6y equals minus 62. And now to eliminate my y, okay, I've got a 6 and a minus 6 this time, so I'm actually going to add the equations together. 9x plus 10x is 19x. My y disappears. Okay, 6y minus 6y is 0. And then 24 minus 62 is minus 38. And then I just need to divide both sides by 19. So we end up with x is equal to minus 2. Now that I've got my x value, I can plug it back into either one of these to find the corresponding y. So taking the top equation, y is 8 minus 3x divided by 2. But x is minus 2, so that becomes 8 plus 6, which is 14 divided by 2, so y is 7. And again, just check that with the bottom equation. Minus 10 minus 21 is indeed minus 31. So x equals minus 2 and y equals 7 satisfy both of my two original equations. So my solution is x equals minus 2 and y equals 7. Don't forget to state your solution after you completed the question. And that is how one would solve linear simultaneous equations in two unknowns. Thanks for watching.